Interactive programming often involves modifying very complex API calls, like this example. When the user has questions, he or she often needs to use search engines to find answers. We present CodeMend, an intelligent system that supports interactive programming by suggesting code modifications based on natural language. Our initial proof of concept implementation targeted at Matplotlib, a popular Python library for plotting figures. Looking for answers for Matplotlib is often difficult. Suppose the user wants to move the legend of this figure to the upper left. She searches Google for Move Legend Matplotlib. Among the top results are documentation pages, which are usually quite hard to understand. For Stack Overflow posts, the user also needs to read through the explanations and code examples, which can sometimes be also frustrating. With CodeMend, the user can make such code modifications conveniently. This is the interface of CodeMend. It has a code editor, a window for previewing the image generated by the code, a query box, and a place for displaying the code modification suggestions. Let's start with a simple example. Suppose the user wants to create a bar chart from scratch. The user can type in a search query, create a bar chart. As she types in a query, the system gives a ranked list of suggested functions based on the query. The user can click on the suggested functions to preview the images generated by the code examples using the function. When she clicks on an image, the associated code example is automatically populated into the code editor. The user can also click on different parameters in the code, and the system will suggest alternative values, which are extracted from the code examples. The user can preview the effect of each of them. Now suppose the user wants to change the color of the bar. She can type in a query, change the color of the bar, and the system will automatically highlight the line that she should change. On the right-hand side, the system also shows what parameters the user should insert or modify. In this case, it is color. The user can click on a parameter and see a list of suggested values. The user can then click on a value, and the system will automatically update the code, and the change is completed. Now let's look at the line plot example we have seen earlier. Suppose the user wants to move the location of the legend. She can just type in a query, move legend, and the system will highlight a line of code that corresponds to the change. The user can then click on the highlighted line to see a list of suggested parameters. In this case, it is the loc parameter. The user can then click on the parameter, then click on the value, and hit update, and complete the change. The user can also easily experiment with a wide range of different options, including other suggested parameters and values. To process a user's query, the CodeMend system converts the code content into a set of code engrams and converts the user's query to a set of tokens. These are then given as input to a neural network model, which predicts which code engram is the most relevant to the user's task. We created a set of simulated tasks for code modification using pairs of images like these. The experiment results indicates that our system can understand a significant portion of the user's queries to improve the developer's productivity.